So today we're going to be looking at how to do advanced plotting in MATLAB. If you want to follow along, have a look at chapter 11 of the Attaway textbook. And we'll be looking at different types of plots, including how to place plots in a figure window using subplotting. And we're going to look at things like three-dimensional surface plots. Okay, so here we go. We're going to start up. So on the screen right here in the editor for MATLAB, you'll see that I have three sets of data, an x vector from 0 to 10, and then two y vectors, y1 and y2, with a bunch of numbers in them. And effectively what we're going to do is set up two graphs with two different sets of y and the same set of x. So the first way we're going to do it is we're just going to plot a regular figure. So we're going to go figure like this. We're going to call it figure 1, and we're going to say plot x, y1, x, y2. And then I'm going to say legend, first set of y, oops, and second set of y, like that. Okay, I'm going to say title, x and y data plotted, and y label, this is the x data and units, y label, oops, label, this is the y, oops, the y data, and of course you need to have units when you're plotting things like that. I will highlight all of this, right click on it, and say evaluate selection. I made a mistake. It says, let me see, error using plot, vectors must be the same length. I have vectors that are not the same length. Let me see, what is length x? X is 11 units long. Length y1 is 10. And length y2 is 10. I made a mistake. Here's how we fix it. We add on, actually we're going to remove some of the x data right there. So we're going to have 10 data points like this. So there you go. We've debugged it. I will run the evaluation one more time. Evaluate selection. There we go. Okay, so we have a regular plot like this. Now, I'm now going to do a second figure where I take the two bits of data, or the two sets of y data, and I'm going to plot them separately. So we're going to go like this. Figure 2, plot, nope, sorry, subplot. I'm going to have two rows and one column like this. So two rows and one column, and I'm then going to say plot x, y1. Title on this one is going to be, this is y1 versus x. X label, this is the x data units. Y label, this is the y1 data units, like this. And I'm going to evaluate this so you can see it. So figure 2, subplot 210, and I made a mistake there. I need to say this is going to be the first piece of data that we're going to have in the subplot. Right click, evaluate, and there we go. So you can see that it's taken up half the space in the figure because MATLAB assumes that there's going to be another figure that goes down below here. Let's see that happen. And actually I'm going to, no, I'm going to leave that alone. I'm going to move this over like this so you can see the whole thing. There we go, like this. Then I'm going to go up here. I'm going to copy this. Oops. I'm going to say subplot. I'm going to remove the figure 2 right here. I'm going to go subplot 212 y2. So this is the second subplot. Okay, so y2, this is y1 versus x. This is the y1 data. We're going to go like this, highlight and evaluate, and look at that. It applies the second plot on there. So there you have it. We have two subplots. Now let's change that around a little bit. And let's copy that and let's do another arrangement for subplotting. We're going to do a figure 3. So change this right here. Another subplot example. And we're going to do figure 3, subplot, and we're going to do the different arrangement. We're going to do 1 row and 2 columns. All right. And everything else stays the same. And then over here, I'm going to do the same for the second subplot. I'm going to say 1 row, 2 columns. I'm now going to evaluate this. And look at that. Here is the difference between the two plots. In one case we had, the original case we had 2 rows and 1 column, and now we have 1 row and 2 columns, right? 1 row and 2 columns, like that. All right. Okay, next up we're going to look at bar plots. And these bar plot examples come from the Attaway textbook. The first thing that we see right here is the setting up of x and y data. So we've got an x-axis set of data in integers 1 to 6, so 1, 2, 3, 4, 5, and 6. Then we have y data being the y-axis data, or the vertical data, nominally vertical, 33, 11, 5, 9, 22, and 3. So I'm going to evaluate this. That just gives me these 2 variables right here, and I have those 2 data sets. Now, the next thing I'm going to do is plot a vertical bar plot, and that vertical bar plot will be the first subplot of 2 subplots in my figure. So that's what this subplot command is. It will set up on the figure 2 different plots. This will be the first one. The command itself is actually pretty simple. It's called bar, x and y, and this will give me a vertical series of bars where the x data is on the x-axis and the y data is on the vertical or y-axis. And then it'll label it as vertical bar plot. So here we go. Evaluate selection, and sure enough, you can see it right here. There are these sets of data right here. You have your x-axis data and your y-axis data. I go back over here. I'm going to plot the second of the 2 subplots, and we're going to do it like this. Subplot 2, 1, 2. So a 2 by 1 subplot arrangement. In the second of those 2 plots, I'm going to do bar H, which is the variation on the bar plots that makes the bars horizontal, and that will change how we look at x and y. We'll see that in a second, and I've put on a title. So I'm going to right-click, evaluate selection, and then I'm going to switch over, here we go, to see the figure. And you can see the figure right here. I'm going to expand a little bit. You can see that the same data is displayed, except it's been turned 90 degrees. So my x data is now on the vertical, and my y data is now on the horizontal. So one of your classmates asked me a really, really good question, and that was, how can we go beyond red, green, and blue in images and figures in MATLAB and add transparency to it? And when we talk about transparency in MATLAB, we're talking about something called the alpha channel. And you'll often hear this when we're talking about different colors in different domains, different engineering applications. But when we talk about it in MATLAB, we're talking about alpha channels, and it's referred to as an alpha command, or the alpha command. And I'll show it to you in a second here. What we're going to do is 2 plots. The first one is going to show a bar chart with some circles that are scattered around in it, and all of it will be alpha channeled, so all of it will have transparency. The second of the 2 subplots is going to once again be the same bar charts, but there's going to be transparent dots placed around it in a scatter plot. And I'll show you how that happens as well. So here we go. In the first subplot, what we're going to do is have a separate figure, then a separate subplot. I'll execute that first. There we go. I'm going to run the bar chart command with some very simple data plotted on it, and I'll place hold on as the command so that we can place other things in the figure. So I'm going to execute that and show you what it looks like. So there you go, some vertical plots, and you can see that laid out like that. So it's nice and simple. Next, I'm going to do the scatter plot, evaluate selection. And you can see that what's happened is that a number of blue dots have been added to the graph. I'm going to then turn hold off. So any changes now that happen will happen to everything basically. And I'm going to add the alpha channel like this. This will add transparency to everything in the plot. Okay, so you can see that the bars have been made transparent, as have the dots. Okay, so that's the first of the two subplots. The next one we're going to do is the second of the subplots. I'm going to I'll do all three of these commands at the same time. I'm going to do the same bar chart. And you can see the difference between a regular bar chart on the right and the transparent bar chart on the left. I'm going to apply the scatter plot one more time. And this time, the big distinction is that the variable s is being assigned to the scatter plot. And this variable is like a handle, and it will allow us to address just that aspect of the figure. Okay, this is a nice trick that you can do in MATLAB. So I'm going to go and execute this. And you'll see that all that's happened is that the blue dots have appeared on the plot, but nothing's transparent at this point. So we're going to say hold off, and now you can see it's still like this. I'm going to call the alpha command, but I'm telling it to apply it only to S, and S was assigned right here with half transparency. So I'm going to go right click on this, evaluate selection, go back and take a look, and I'm going to expand the figure. And you can see that only the circles in the second of the two plots has been made transparent. You can actually see the transparency. Right. Zoom in here. The transparency is really obvious in that circle, and you can see some of the lines from the bar chart going through it. Okay, and there you have it. So full transparency on everything in the chart, and some selected transparency on some objects in the chart. Next up, we're going to see how we can visualize data in 3 dimensions. So MATLAB is fantastic for doing 3-dimensional plotting. And one of the ways that you can do it is 3-dimensional bar charts. So this is kind of neat. So what we're going to do is show you some data in matrix form. So I'm going to execute this first line right here. So I'm going to call a variable mat equal to spiral 5. So it's going to create a set of data in a spiral pattern, and you can see here in the command window, it's basically 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, a 5 by 5 matrix arranged in a spiraling pattern. So if you take a look at these values, you can see that it goes 25, 24, 23, 22, 21, 20, 19, 18, and you can see that it spirals inwards until you get to the center right here at 1. So it's created a spiral pattern, and that allows us to send it into a function called bar3, so 3-dimensional bars that will be laid out using this really simple 2-dimensional matrix series of data. All right, so I've now got mat. I will execute the rest right here, with mat being the input argument, and you can see that the top value right here is 25, and it goes down here to 21, down here to 17, down here to 14, down here to 10, etc. Now, 3-dimensional charts are fabulous to manipulate, and you can actually see how I've used the rotation tool in MATLAB to turn it and to be able to inspect different aspects of the chart. So there it's 2-dimensional. Now it's 3-dimensional. I can look underneath, etc. So you can do some really, really neat stuff with MATLAB 3-dimensional charts. You can look all the way around like this, and you can lay it out in a form or a direction that most fits the message you're trying to get across. So the next thing I'm going to do is show you how to do a surface plot. So we've started with a spiral that was turned into a 3-dimensional bar chart, and I'm going to repeat that one as a subplot. So I'm going to say figure 4, subplot 2, 1, 2. So the first of 2 subplots, and I'm going to say mat is equal to spiral I'm going to do a 5 by 5 spiral like that, and I'm going to say bar 3 mat. All right, so I'm going to hit enter, and sure enough, there we have the first of two different plots in a figure, and this one is going to be the bar chart in three-dimensional form. Next, what I'm going to do is create two other arrays, or two other matrices that represent x and y. So the mat variable represents the z data, or the vertical data. I need to set up two other variables in very regular pattern intervals that show x and y data. So I'm going to set up x here. So x is going to be equal to 1, 1, 1, 1, and 1, so 3 times. 2, 2, 2, 2, and 2, 5 times, sorry. Then 3, 3, 3, 3, 3, 5 times. 4, 4, 4, 4, 4, and 5, 5, 5, 5, 5. So effectively what I've done is created an array called x, and we'll just see it like this, where the first row is all equal to 1, the second row is all equal to 2, 3, 4, and 5. And it's again arranged in a 5 by 5 pattern because we have z data in a 5 by 5 arrangement. I'm going to do y this time, and y is going to be equal to a very similar type of pattern, but I'm going to effectively transpose it. I'm going to turn it by 90 degrees. So I'm going to say 1, 2, 3, 4, and 5. I'm going to actually copy and paste this. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and the last time 1, 2, 3, 4, 5, like this. And I'll make it displayable so you can see that effectively it is a 90-degree turned version of x, where the 1, 2, 3, 4, and 5 are arranged in columns rather than in rows. So now I have three matrices, x and y, which will represent my horizontal data, and the mat matrix that represents my vertical data. So then what I'm going to do is I'm going to type in the surf command, surf, like this, and I'm going to say that I want x, y, and mat, like this. And it will create, oops, actually I'm going to make a subplot out of that. So I'm going to say, let me just make sure that I get the subplot right. Subplot 2, 1, 1. So I want to do subplot 2, 1, and 2, like this. And a surf. I hit enter. I get my figure out. I'm going to expand it so you can see it. What you have here are effectively two ways to demonstrate or to show the same kind of data. So I'm going to rotate this to arrange it almost in the same pattern. There we go. Like that, I believe. Yeah, there we go. Now the colors don't quite match up, but the slopes should. So we start at 25 here in the corner, 25 in the corner. We work our way down to about 21 there, and about 21 there. And down to this corner, it represents this corner right here, and the 5 corner here is that 5 corner right there. I'm going to rotate both. You can see this. There's the rotation, like that. That flattens out. Okay, so we have two three-dimensional plots. This is the surface plot. Now, in this case, for this sort of low-resolution kind of three-dimensional plot, the 3D bar plot looks better. But you'll see that as we get more and more data, if we can make a surface that is it has a higher density of information, you'll see that the surface plot actually looks fantastic. So there you go. So this is two different ways of demonstrating three-dimensional data in x, y, and z. Okay, so another trick that is often really useful is to take a low-resolution series of data and add all sorts of interpolation points between the known data points. And this can allow you to create really, really smooth three-dimensional curves or three-dimensional shapes in your plots. So we're going to repeat the example that we just did. I'm going to set up a matrix of spiraled data like this. So we've seen this before. It's a 5 by 5. I'm going to repeat the command for X. So a 5 by 5 matrix as well, arranged in this 1, 2, 3, 4, and 5 pattern in terms of its rows. I'm going to do the same thing with Y. So here we've got 1, 2, 3, 4, and 5 arranged in columns. And I am going to do, let me see, I guess I'll do 4 subplots. I'm going to do the first subplot like this. I'm going to do figure 4. I'm going to do subplot 2, 2, and 1. So 2 rows, 2 columns, first piece of data. And I'm going to do bar 3 mat. And there we go. So I've got the very familiar 3-dimensional bar chart shown. Okay, next up, we're going to do subplot 2, 1, no, 2, 2, and 2. So the second plot of the 2 by 2 arrangement, and I'm going to do it as a surface plot. So surface, surf, and I'm going to do surf X, Y, and mat like this. I'm going to switch over to the plot, and you can see that I have, I'll expand this out a little bit. I've got both my 3D bar chart and my 3D surface plot. Okay, here we go. Next, I am now going to do something called interpolation. So I'm going to add, well, let's add 4 points between each of the existing data points on my X matrix, my Y matrix, and my mat matrix. So my X and Y horizontal data and my Z vertical data. So I'm going to say that mat interpolated is going to be interp2. That's the type of interpolation function we're going to use. I'm going to say that I want to apply this to mat, and I want to add 4 additional points between the existing points. So I'm going to hit enter, and you'll see a whole lot of data being added in. And you can see lots of decimal points in here, lots and lots of data points. You can see that there's lots of new columns. And if we take a look at the size of mat, it was a 5 by 5. If we take a look at the size of mat interp, so mat interpolated, it's now 65 by 65. We have added in a whole lot of points. So I'm going to do the same thing to X. So we're going to have X interp is equal to interp2 X. And I want to add 4 data points like this. Same deal, lots of additional points. If I go size X interp, it should be a 65 by 65. Then we're going to do a Y interp is equal to interp2, and we're going to do that to Y, and we're going to add 4 additional points between existing data points like this. So again, lots and lots of data. So size Y interp, we can see it's a 65 by 65. All right, so now what we're going to do is we are going to create another 3D bar chart to compare it. We're going to go and do subplot 2, 2, 3. So this is the third of 4 subplots in the figure. I'm going to do bar 3, so a 3-dimensional bar chart with mat interp like this. Hit enter, switch over, and look at that much higher resolution spiral in the figure right here. So if I do, yeah, so you can see it like this. Now, it's not truly representative of what the data actually looks like, but it adds a whole lot of extra data points. So it doesn't add much to the bar chart, but you'll see that with the spiral plot in surface mode, it looks a little bit more interesting. So next, we're going to do subplot 2, 2, and 4. We're going to do surf, and let me see, surf, we're going to do surf and X interp Y interp, interp, and we're going to do mat interp like that. Okay, hit enter, switch over, and we can see that there's a whole lot more points added to the data in this one right here. Oops, let's click on that. just like that. So let's take a look at the difference. So in some cases, it is a good thing to do, some cases not. It depends on what application you've got, but now you can see how we can generate both 3D bar charts and surface plots. As well, we can add interpolation points in order to add a little bit of smoothing or continuity to your surface plots.